Yeah, good afternoon, Pat. Today we'll be doing with NEET 2001 formula revision for from class 11 physics. Okay. So today I'm going to review the formulas from laws of motion and projectile motion. Today we'll be doing with first we'll see what are the laws of motion is there. Okay, and what is the formula is related with this. Okay. And then we are going to do with the projectile motion. So like a revision. So just we are going to touch all the concepts. Okay, what is the important formulas is there in this particular concept. That's it. Okay. Yeah. The first thing we are going to see what are the three fundamental laws is there. Newton's first law, Newton's second law, and Newton's third law. There are three basic laws is there. Okay, so Newton's first law is going to be say about the inertia. Okay, second law it's going to explain about the force is equal to mass into acceleration. Okay, third one, every action equal and opposite reaction, everything will be reactional force will be there. Okay, now there are three laws is there, first law, second law, third law. So today we are going to discuss all the concepts, okay, all the formulas for NEET 2001 point of view. Okay, so upcoming NEET exam, so formula revision I'm going to give. So every day we are doing the formula, okay, from class 11. So today also now we are going to do with the formulas revision. Okay, the first thing, formula. Before going to the formula, just I'll be relate one by one. Then we'll go with the concept. Okay. So displacement, S symbol. It is unit is meter. Okay, it's called vector quantity. So whatever is related to displacement, everything will be vector quantity. Velocity, velocity is displacement by time. It's going to be meter per second. It is also vector quantity because of displacement. Okay. The next one, acceleration. Acceleration is equal to rate of change of velocity or velocity by time. Velocity is meter per second by second. So meter by second square. This also will be vector quantity. Okay, velocity is the vector quantity. Okay, now what is the force? Force is equal to mass into acceleration. Force is equal to mass into acceleration. Mass unit is kg, acceleration unit is meter per second square. So from denominator, if you are taken second square as numerator, kg meter second minus 2, which is equal to 1 Newton. So 1 Newton is equal to kg meter second minus 2. Okay, this what we can have the force relation. Force is a vector quantity. Force is a vector quantity. What is force? Something it's going to cause the change in shape or dimension or position or state of its state getting changed means some force is applied. Okay, so that's definition of force. So now I'll be doing with one by one. First we'll do inertia. What is inertia? There are three types of inertia is there. Inertia of motion, inertia of rest, inertia of rest, and inertia of direction. There are three types of inertia is there. Okay, inertia of motion. The moving object will be continuous state unless otherwise the external force is applied. Okay. So without applying external force, the object is not going to become as a rest. Example. So according to the statement, one football I am taken, just it's moving on the floor. At one point, it's become as a rest. Why? No, because of friction force. Because of frictional force is there. Okay. So here, when the object, unless otherwise the external force is there, the object has to move till infinite. That is the inertia of motion. Inertia of motion. The moving object will become rest only the external force is applied. Okay. Imagine I have one object here. Okay, my object here. When this going to move, when we applied the force, that time only it's going to move. Okay. The rest object will be changes the state when we applied the external force. Okay. and also inertia of direction. Okay, so I can give the example. Okay, when the bus is there, okay, you are sitting inside the bus, okay, when bus is start moves, you will move forward, you will move backward direction, because you are in the state of rest. You are going to change the your state. Okay, so that effect you can feel when the bus is moving forward, you will move backwards. It's all because of you are changing the state of your state. Okay, so same thing when the moving bus, when they applied the brake, okay, you will move forward direction. Okay, because you are in a motion. Okay, so suddenly driver supplies the brake, will become, you will try to become as a rest. Okay, so that's the reason you are going to change your state. Okay, unless otherwise the external force is there, you are not able to change your state. That's the reason you are moving forward. Okay, the next one, when the bus is turns left side, you will move right side. Okay, bus is turn left side. When the turning is there, when the bus is moving left side, you will move right side. Okay, so that's the inertia of direction. Okay, so the moving object, unless otherwise the external force is there, it's not going to become as a rest. Okay, same thing for rest object also. Okay, same thing for direction also. These are the very good example. So three types of inertia. Okay, in case they are asking one example, why when we are shaking the tree all the fruits is coming out. Okay, because the fruits are rest. When you apply the external force, the fruits, it's going to change its state of rest, so because of it only it's coming out. Okay, otherwise you are hitting stick with the uh, carpet. Okay, all the dust particle will come out because it's going to be show the state of changes. Okay, so rest particle, it's going to do some process, that's the reason it's coming out. Okay, already I told you inertia of direction. When the bus is moves left side, you can move as a right side, it's going to be the inertia of direction. There are three types of inertia is there. Okay, next, now force. So that's it, inertia. Okay, the more mass is there, it's going to offer us the more inertia. Okay, m1 is a smaller mass, m2 is a bigger mass. Okay, which will be offer more inertia. The second case is going to offer us the more inertia. Okay, next, force. Force is equal to mass into acceleration. Okay, so it's become as the under second law, Newton's second law. Okay, so force actually, in case they are asked, state Newton's second law. Force is directly proportional to rate of change of momentum. So what is momentum? Momentum is equal to mass into velocity. The unit of momentum, product of mass into velocity, we can take it as momentum. Unit of mass is kg. Unit of velocity is meter per second. So unit of momentum is kg meter. From denominator, if you are taken second as a numerator, second minus 1 we can get. Okay, the unit of momentum, m power 1, l power 1, t power minus 1. It is a dimensional formula of momentum. It is a final SI unit of momentum. Okay, now I got what is the unit of momentum. Okay, now we'll come for the second law, Newton's second law. Okay, Newton's second law says the applied force is directly proportional to rate of change of momentum. What is momentum? Momentum is equal to mass into velocity. F is equal to k times. When we are removing directly proportional, you should include as a k, d by dt. Momentum is mass into velocity. Mass you can take it common outside. So k times of m dv by dt. Rate of change of velocity is how much? Rate of change of velocity is how much? It's the acceleration. So force is equal to k times of m a. Okay, a is equal to dv by dt. That's the reason. K is equal to 1. So force is equal to ma. Force is equal to ma. It's very simple. Okay, now unit of force is Newton. So 1 Newton is kg meter second minus 2. Okay, in case same unit, it is SI unit. SI unit which is follow as the MK system. Okay, same unit if you want, what is dyne? So same equivalent unit, gram, centimeter, second minus 2. If you want to convert Newton to dyne, 1 Newton is dash dyne. So 10 power plus 5 dyne. Okay, 1 dyne is dash Newton. Opposite to that, 1 dyne is 1 divided by 10 power plus 5 Newton. Okay, it's going to be 10 power minus 5 dyne. Okay, next, impulsive force. Impulsive force. Okay, what is impulsive force? Huge force will be acting in a short time period. Okay, lot of force will be acting in a less time period. We can take it as an impulsive force. Okay, so here F is equal to ma. According to equation of motion, there are three equations of motion is there. V is equal to u plus at, S is equal to ut plus of at square, v square is equal to u square plus 2as. Okay, I am taken this equation, v is equal to u plus at. Okay, from here I am going to calculate what is a. So v minus u is equal to at. T you can bring denominator. So v minus u by t is equal to a. Okay, so F is equal to ma, no? F is equal to m times of v minus u divided by t. It is the force another formula. Okay, if you are taken this side as a time, force into change in time is equal to mass into final velocity minus mass into initial velocity. Okay, so final velocity it's called final momentum. Initial velocity is called initial is equal to force into time. So like this we can take it. Now it is called impulsive force, huge force acting in a short time period. Based on this also, the neat question is asked previous year. Okay. So what is the unit of this? Newton meter we can take it. So Newton is kg meter second minus 2 into second. Time is second. Okay, into second. So plus 1. So kg meter second minus 1 minus 2 plus 1. So we get kg meter second minus 1. It is a impulsive force as a unit. Okay, if you want dimensional formula for impulsive force, m power 1, l power 1, t power minus 1. It is the a dimensional formula for impulsive force. Okay, next. It's nothing but it's equivalent to the momentum. Okay, next. Newton's third law. Every action equal and opposite reaction. Okay, from here you need to know where it can be applicable. Okay, application. There are five, 6 places you should keep it in mind. Many places is there. Okay, these are the main content you need to know. Okay, when we fired the gun, okay, the bullet is moving. It's called action. The gun is moves backward. It's called reaction. Okay, when the rocket through the nozzle that smoke will come. This is called action. The rocket is moving is called reaction. Okay, actional force, reactional force you should know. Okay, so we have boat. Okay, you are pushing the water backside. Okay, it's called action. The boat is moving forward, which is called reaction. Okay, when some person is jumping from the boat, okay, he moves forward, boat moves backward. Okay, it's called first jumping is action, so moving backward boat is called reaction. So action, reaction, everything is over. Newton's third law is over. Next thing, conservation of momentum. Conservation of momentum. Momentum symbol we can take it as a P. M1 U1 plus M2 U2 is equal to M1 V1 plus M2 V2. Momentum is conserved. Neither we create nor we destroy. It is before momentum. This is after momentum. After collision, this is before momentum. Before momentum is equal to after momentum. This is going to be conserved. Okay. Two ball, M1 mass, U1 velocity, M2 mass, U2 velocity. It's going to collide. After collision, it will move in opposite direction. M1 mass V1 velocity, M2 mass V2 velocity. Okay, collision equation. In case kinetic energy is conserved means of M U1 square plus of M2 U2 square is equal to of M1 V1 square plus of M2 V2 square. It is called conservation of energy. Now we are going to do with the lift problem. The person is standing on the lift. Okay. Weight is acting mg will be down. Reactional force will be upwards. So in this case, when the lift is rest, okay, reactional force R is equal to mg. First case. Imagine the lift is moving with uniform velocity. That's going to be acceleration will be 0 when the lift is moving with the up or down. Up or down. The lift is moving with uniform velocity. Okay. So whether it's moving up or whether moving is down, the velocity is uniform. When the velocity is uniform, that time acceleration will be 0. Okay. In this case also R is equal to mg. Okay. Imagine the next case, lift is moving up. The person is standing in a lift. Lift R will be upwards, mg will be downwards. Okay. Lift is moving upwards, mass into acceleration. Okay. So R minus mg. R is greater than mg. Then only the lift can move upwards. R minus mg is equal to ma. It's very simple. This is only applicable when the lift is moving up. Same condition when the lift is moving down. Okay. So the person is standing inside the lift. Okay. The lift is moving down. Mg will be downwards. R will be upwards. Lift is moving down. Ma. Okay. So in this time, I'm going to subtract mg downwards minus upwards R is equal to ma. How come I'm writing this as a greater? Because lift is moving down. So mg is greater. Okay. Before case lift is moving up, R is greater. Okay. This equation you can use to calculate with the up and down lift moving. Okay. Next problem. Next condition I'm going to give you. This also one of the time neat question. We have pulley system. Okay. So left side I have one mass, right side I have one mass. Okay. The full system is moving this side. Okay. So it is M2 mass, it is M1 mass. Okay. Downwards will be gravitation. Here downward will be M2 times of G. Here M1 times of G. Upwards will be tension. Upwards will be tension. Full system here it's moving down. So M1 times of A. This side M2 times of A. It's going to be acceleration will be same. So two equation I am going to write. First left side, then right side. Okay, left side T. T is greater because it's moving up. Okay, T minus M2 times of G is equal to M2 times of A. Okay, it's from left side. Right side you want, this is downwards will be greater. That's M1 times of G will be greater. M1 times of G minus T upwards is equal to M1 times of A. When we are adding these two, T get cancelled. M1G minus M2G is equal to M1 plus M2A. If you want what is A is equal to M1G minus M2G. This you can bring as a denominator divided by M1 plus M2. Numerator also you can take G as a common. M1 minus M2 G divided by M1 plus M2. I got now what is acceleration of the pulley system. Okay, when the string is moving on the pulley, you can write like this: M1 minus M2 times of G divided by M1 plus M2. It's very simple. Okay, laws of motion. This is the very basic formula I am given. Next I'm going to do with projectile motion. Okay. There are two types of projectile motion. Is there? One is off projectile motion. Another one is a full projectile motion. First we will see off projectile motion. Off projectile motion. Okay, when we are standing on the top of the building, okay, we throw the ball. Okay, your aim is going to be this point. Okay, but definitely it's long distance. It's not going to move like this. It will make us the off projectile motion. Okay, so when the object is covering off projectile motion, you need to know some basic formulas. Then only if you got this type of problem, means easily you are able to solve the solution. Okay, first you need to know trajectory equation. Trajectory equation. So y is equal to k x square. This is the equation is proved. It is off parabola. Okay. So now, what is trajectory equation? Y is equal to g times divided by 2 v naught square. It's a v is a velocity which we throw x square. Okay. This is called trajectory equation. If you want time of flight, okay, time taken, t is equal to root of 2h divided by g. What is g? Gravity. What is h? Height of the building. Okay. The next one, velocity at particular instant. Anytime, velocity at particular instant. I want what particular instant. So root of v naught square plus g square t square. How come I wrote like this equation? In case here I want the velocity. Horizontal velocity is constant because there is no gravity. Vertical velocity will be the different. Okay, it's g times of t because initial velocity is 0 at y-axis, because when the object is started you are given x-axis velocity which is maintaining constant. Initial velocity y-axis is 0, v is equal to u plus at. Initially if you are taken as 0 means gravity will be 9.8, v is equal to gt. Okay, that is the reason we got velocity at particular instant is going to be root of v naught square plus g square t square. Okay, actually I used as the Pythagoras theorem. If we want, this is the velocity v instant. Okay, I made it as a small triangle. This side is v naught, this side is gt. Okay, it's very simple. Now I got velocity at particular instant. In case they asked angle, you can take it as tan theta. Tan theta is equal to opposite by adjacent. What is opposite here? Opposite is gt, adjacent is v naught. Okay. So because this is the velocity instant at particular instant, this side is v naught, this side is gt. Already I told you how we got. Okay. Theta is equal to tan inverse of gt divided by v naught. Okay. So this what we can get as the off projectile at particular instant. What is the angle of projection? Okay. If you want distance, okay, so you can height of the building. So height of the building is going to be t square g divided by 2. Like that also we can write. Okay, so s is equal to ut plus of at square. No, same equation. U is 0 means you will get h is equal to t square g by 2. T is the time, g is the gravity. Okay, so you can substitute this, means you can get the height of the building also. Okay, it is this equation is only applicable in off projectile motion. Next we are going to do with full projectile motion. Okay, full projectile motion also we have everything, all things. Okay, trajectory equation, maximum height, maximum range, okay, everything we have. Maximum range, maximum height, okay, time of flight, everything we have. Okay, one by one we'll see. What is maximum h maximum? Maximum height the object can be traveled. V naught square sine square theta divided by 2g. Maximum height of the object. Only I am giving the formula revision. If I am doing the concept means it will take lot of time to explain. Okay. The next thing, what is the range maximum? What is the maximum range the object can move? Range maximum. So maximum range of full projectile V naught square sine 2 theta divided by g. Okay, when the theta is 45 degree, when the theta is 45 degree, sine 2 theta, it's going to be 90 degree. Okay, sine 90 answer will be 1. So maximum range, it will be when the angle is 45 degree, the object can move with maximum range. Okay, when the object is thrown 45 degree from the ground, okay, it will go maximum range. Okay, maximum range it will cover. Okay. Next one, trajectory equation, and it is time of flight. Okay, time of flight, if you want time of flight, it's going to be 2 times of v naught sine theta divided by g. Okay, v naught is the initial velocity, theta is the angle how much you throw, g is the gravity. Okay, if you know this, easily you can calculate what is the time taken for full projectile motion. Okay, next thing, trajectory equation. Okay, trajectory equation, which the equation is proved, it's a parabola. Okay, for trajectory equation is very important. Y is equal to ax minus bx square. If you prove this means it is going to be the full parabola. Okay, so here we got y is equal to x tan theta minus g divided by 2 v naught square cos square theta x square. This fully we are taken as b, this we are taken as a. So if you are taken like that means we'll get y is equal to ax minus bx square. Okay, if you got like this means it's going to be the full projectile motion. So of projectile, full projectile, everything we saw. Okay, so now what I am doing every day, I am given the formula revision for upcoming NEET exam. So as soon as possible I will complete full 11th concepts. Okay, if you are following my class means it will be very useful for revising all the notes. Okay, thank you for watching my video. So next video I'll be upload as soon as possible. Thank you everyone. So today I'm doing in this live class for NEET chapter wise formula revision. Okay, so I'm going slowly step by step. Okay, you can follow me to understand all the formulas chapter wise. Okay, then I'll be doing chapter wise all the previous year NEET questions. Thank you, bye bye, we'll see you next class. Thank you everyone.